In this video, we are going to find Laplace transform of two functions using the definition. The definition is Laplace transform applied to a function of t is defined to be as the definite integral from 0 to infinity e to negative st times f of t dt, which is an improper integral because one of the limits is infinity. So the first example is find Laplace transform of e to the power of 3t. So the definition says is integral from 0 to infinity e to negative st times e to 3t dt. So this equation or this integral can be computed or can be rewritten as e to negative s minus 3t dt. I use the exponents properties. A to b times a to c is a to b plus c. So we ended up with this integral, which we are going to write using limits because it's an improper integral. So its limit as n is approaching infinity of limit from 0 to n of e to negative s minus 3t dt. Now this integral can be calculated easily because it's in terms of t. So this is the variable, negative s minus 3, it's considered a constant. So we get limit as n is approaching infinity of e to negative s minus 3t over negative s minus 3 evaluated from 0 to n, which ends up being limit as n is approaching infinity of e to negative s minus 3n over negative s minus 3 minus e to negative s minus 3 times 0 over negative s minus 3. So when we calculate this, first let's make an observation. If this quantity here, s minus 3, so if s minus 3 it's a positive quantity, which means if s is greater than 3, I can write it at the denominator. So I can write 1 over negative s minus 3 e to negative s minus 3 times n. 1 over negative s minus 3 e to s minus 3 times n. Because this being positive, this whole quantity here being positive with the negative is negative, so then at the denominator we don't write the negative anymore. A good example would be to just consider s minus 3 to be 10, for example. Then you have here e to negative 10 to the n, so then when you write it here it's 1 over e to 10 to the n. And then plus, because this minus with this minus gives me plus, e to 0 it's 1, s minus 3. Now this limit here, it's actually approaching 0. Why? Or it's equal to 0, because we get 1 at the numerator, and at the denominator we have e to infinity, which is infinity, so 1 over infinity is 0. So this quantity here is minus 3, because we set that condition to be positive. Now we know for sure that we have e to infinity, which is infinity. So then we can actually conclude that Laplace transform of e to 3t of s, it's 1 over s minus 3. So what Laplace transform did, it transformed from a function in t into a function in s. Now let's look at another example. Let's find Laplace transform of e to 2t cosine of 3t. And I also want to remind you that if we didn't set the condition for the previous, for example 1, if we didn't set the condition s minus 3 greater than 0, so if s minus 3 was less than 0, our integral would be divergent, so we wouldn't be able to calculate the Laplace transform. So this condition, it should show up here. Laplace transform is of e to 3t is 1 over s minus 3, but as s is greater than 3. Let's talk about the second example. So again, I want to do this problem using the definition. There are tables also which we are going to use later. But now let's use the definition. So it's integral from 0 to infinity of e to negative st times our function, which is e to 2t cosine of 3t dt. And this would give us Laplace transform of function would be a function of s. So the next thing that I'm going to do is actually combine these two, copy the base and add the exponents, and I will actually write it in this format. So instead of just writing negative st plus 2t, I choose to factor out a negative t and get s minus 2, just so that it's easier to write the condition s minus 2 is greater than 0 and s greater than 2, which helps me make this improper integral as an actual to converge. And then times cosine of 3t dt. Now this integral, it's pretty obvious that it's going to use integration by parts, so let's start doing that. So first I decided on the u and v, and now let's write the limit as n it's approaching infinity of, and we will have uv minus v du, right? So it's going to be uv e to negative s minus 2t times sine of 3t over 3 from 0 to n minus integral from 0 to n of v, which is sine of 3t over 3 du, which is negative. So this is negative. I'm going to put this positive, s minus 2 e to negative s minus 2 t dt. So the first limit as n is approaching infinity, we get e to negative s minus 2 n sine of 3n over 3, and then it would be minus, and we would replace the 0, but sine of 0 is 0, so I'm not going to write the second term. And then plus limit as n is approaching infinity, and I'm going to write this integral, but the quantity s minus 2 comes in front, so we will have, and I can put over 3 as well, so it's sine of 3t and then e to negative s minus 2t dt. So the limit as n is approaching infinity, the first limit, what do I notice here? Again, I'm going to set the condition s minus 2 has to be greater than 0 or s greater than 2. Why is that important? Because if this quantity, the green one, is positive, I can put at the denominator e to s minus 2 to the n. And I know that quantity s minus 2 is positive. And then sine of 3n. And we can, and then I'm going to just copy this one, limit as n is approaching infinity. And this integral here, it's actually, again, integration by parts. So let's pause it and figure out u and v and so on. So using the same pattern as before, we chose u to be to negative s minus 2t, du is the derivative of that, dv is sine of 3t dt, and v is the integral of that, which is negative cosine of 3t over 3. So when we write out the integral is going to be uv, so minus cosine of 3t over 3 e to negative s minus 2t from 0 to n minus integral from 0 to n of v du, so negative, well, there is a negative, I'm going to put it positive here, s minus 2 e to negative s minus 2t dt. And close. Now let's have a discussion about the first limit. This limit here, what is this approaching? So the denominator, it's approaching infinity, right? This quantity is e to infinity. Now this quantity here is sine of 3n. Well, sine of 3n, when n is approaching infinity, it's some value between negative 1 and 1. So that means the numerator is a finite number and the denominator is infinity, which makes the whole quantity approach 0. So then we end up with s minus 2 over 3, and then limit as n is approaching infinity, and let's do the parentheses. Well, when we set n equal to, when we set t equal to n, we get negative cosine of 3n over 3 e to negative s minus 2 to the n, and then minus, and we set t equal to 0, so I already have a minus here, so plus cosine of 0, it's 1 over 3 e to 0, which is 1. So we leave 1 over 3, and we just evaluated this whole quantity. And then minus, I can move out s minus 2 over 3, integral from 0 to n of cosine of 3t e to negative s minus 2t dt. So let's make a little bit, let's arrange it a bit more. So s minus 2 over 3. Now this quantity here, this one, again can be moved at the denominator. So that's going to go to infinity as again s is greater than 2. The numerator is cosine of 3n, so that is again a finite number between negative 1 and 1. So this whole quantity that I highlighted in yellow is going to approach a 0. I'm not going to explain that again because I already explained it above for sine. And so this is going to be 0. And then we get times 1 over 3. So let's not forget this quantity here, times, and then everything that is inside parentheses, minus s minus 2 over 3 times, well, this whole quantity here, it's actually what we started with, right? So is exactly Laplace transform of e to 2t cosine of 3t. So I'm going to write an equation from the left-hand side. It's exactly the Laplace transform. I'm just going to write it as I. It's going to be easier to compute it. And then s minus 2 over 3 times 1 over 3 minus s minus 2 over 3 times I. Because I just used that substitution instead of this Laplace transform, I wrote I. So open parentheses and solve for I. So here I showed work how to get I by itself. So we multiply s minus 2 with each of them, and then we move the whole quantity, this quantity, with I on the left hand side. We factored I out, and then I did just some algebra. And so we ended up with I equals s minus 2 over s minus 2 squared plus 9, but I was Laplace transform of e to 2t cosine of 3t of s. So we ended up with s minus 2 over s minus 2 squared plus 9, which if you check in the formulas, you're going to see that it's exactly the same thing that they have. But we proved it with a definition. I hope it helps.